Okay, Dragons, I fear that the voice is going out. Might be getting sick, so I'm going to do the notes, and you can take it nice and slow at your own pace, fill these in, and then ask questions along the way. So today we're looking at what is known as a system of equations. So basically what we're going to have is two lines playing on the same playground. So if we have two lines, there are three things that can happen, and I'm going to show you each of those situations. So first of all, if I have my two lines right here, one possibility is that they could be parallel. Obviously a picture of parallel lines. Notice I have sloped triangles, and I identify the y-intercepts. So because these two lines will never cross, they have no solution, zero solutions. When you see parallel lines and they say, what's the answer to the system? You're going to say there isn't one because the two lines don't cross. So I notice that both of them have a rise and run of 3/2. They're both positive rises and runs. The only difference is that the y-intercepts. This one down here, which I call line 2, and this one line 1. Line 2 has a y-intercept of 0. You really don't have to write that, but you can. And line 1 has a y-intercept of 3. So if we look at the slopes are the same, but the y-intercepts are different. Zero solutions. Let's look at the second scenario. What can happen on our linear playground is the two lines can cross, and it doesn't matter how. They can cross in any manner. They can be perpendicular, they cannot. It really doesn't matter. If the two lines touch at one point, they have one solution. And to be honest with you, this is really what we're looking for in this unit. When two lines cross each other, what is it? Okay? So as we look at this one, we got the slope triangles down here. I notice one slope is positive, the other is negative. I do my rise and run. So I know that this guy, which I call line 1, is I go down 1, so that's negative, and then right, which is positive, and I go over here, not to the intersection point. And I got a y-intercept of 4, so that's the equation. I'm getting this just by observation. Okay? And over here, same thing, up 3, right 2, that's my slope, and the y-intercept is -3. So what's the deal with the slopes? The slopes are different, and I don't care how. And the y-intercepts are different. So whenever you have different, your two lines are going to be guaranteed to cross. All right, what's the third thing that can happen? The third thing that can happen is kind of weird, okay? We actually can have two lines that wind up on top of each other. That means that they share all of these points, not just one, like in the previous example. They share all of them. So if you have two equations, and by the way, these are the equations that make this line. You got to trust me, or solve for y and figure it out. You notice the equations are different. But if I solve both of them for y, they wind up giving me the same thing. So you may have a system made up of two equations that wind up being the same line. If that happens, you have an infinite number of solutions. Infinite, I-N-F-I-N-I-T-E. Infinite number of solutions. So if we take a look at our three things that can happen on the linear playground, the two lines can cross once for one solution. They can not cross at all, being parallel, or they can wind up being the same line and sharing all of their points. All right, so let's go ahead and fill in these right here. Solutions are points that the two lines share, known as the intersection. All right, so to write a system of linear equations, use all the techniques from previous units to piece together equations such as identifying slopes and slope-intercept form. Okay, so if I give you this, all right, or if I give you pictures, you should be able to look at this and give me the equation just by looking. You can do a linear regression, stat edit, on your calculator. Got to have at least 2 points from the line. Or we could use the 3-box method and use the point slope equation. Okay? So, let's take a look, and I'm going to talk you through this. All right. So I have two lines. They have one solution because they're crossing. They're crossing right here. Yay, there's an answer. There's one solution. This is the answer because this is where the two lines cross. But we're really not looking for answers today. We're looking at the equations that make up the system. So what did I do first? I identified some points for line 1. I called it line 1 and line 2. I did a slope triangle on each because I need to try to find the slope. So on line 1, I did 6 over -9. That reduces to -2/3. So I'm starting to construct my equation. And I did the same thing for the other guy. Up 5, left 2. So that's a negative slope. Okay? I could have gone down 5 and right 2. It doesn't matter. I think that's what I wrote over here. Same thing. This one, I can look and see the y-intercept. The y-intercept is at -4. -1, -2, -3, -4. So this guy was just done by just looking. All right? All we did was we just looked over here and we found it. Okay? Over here, we have a problem. The y-intercept is not clear. So, instead of just guessing, we're going to go back and say, I'm going to take 2 points, and if I do a regression, it's going to tell me the y-intercept. So I picked 5, 0, that's this point right here, and -4, 6, that's this point right here. 2 points on the line, and I'm going to do a regression. So now if I go to Stat Calc 4, I notice my y-intercept is 3.3 repeating. Now, you either know that that's 3 1/3, or you go to a blank screen and type in 3.3 repeating and do math, enter, enter. And I get 10/3. So that's where I got that right here. Okay? So immediately I can now come over here and say, hey, here is line 2 from my picture, and here is line 1. So the answer is C. All right. On the back side, if they give you tables, what you need to do is you need to do a regression for each of these. So, if I take a look at, let's see, that's this one right here. Remember, this is X, Y, X, Y, X, Y. So these are all my X's in L1. These are all my Y's in L2. So you're doing a regression to get started with the equation. So that's where I got this guy right here. Y is equal to -1x plus 10. Okay? And then if I look at my other guy right here, this is kind of smaller, but I do a regression for this one. And I wind up with that equation. So to get started, you need to do a regression when you're given a table. All right? In order to get some equations happening here. Now, this is going to look a little confusing, but I'm going to talk you through it, okay? All right. So all of these answers over here are in whacked out form. Okay, standard form. Okay? So what I need to do is I need to start solving for y, or I need to try to start figuring out things that start looking like the numbers that I have here. All right? So the first thing that I did was I went through over here and I said, you know what? All of these numbers can be divided by 3. So if I divided all of these by 3, I get this. And I said, hey, there's a 10, and I have a 10 from my regression. What if I move this x to the other side? If I do that, I get this right here. And so that's why I said this guy right here is line V. So that means this is line V, but there's no line V over here. So just by looking at my line V regression, Okay, I can eliminate answer choice C. So this is line V. Might even want to put that 3x plus 3y equals 30. Okay, so then I'm going to come over here and say, all right, it's either this guy in orange or this guy in blue is going to be my line Q. All right, so if I come over here and, oh my goodness, I have to solve for y. Move the x to the other side, change sides, change signs, divide by what's in front of y, which is a negative, and negative divided by negative is a positive. And I notice that compared to what I have right here, it is not the same. I guess I wrote it down here. So this is line Q from my regression. And this is what I get from this answer choice, and they're not the same. So I'm not going to pick A. So that leaves B. B is the answer, but just checking this one, if I solve this for y, notice what I get. I get the same thing I got from my regression, okay? So basically, it's do a regression to get started, and then solve for y until you can match it up to your regression, okay? Same thing over here in example number 3. We're going to do a regression for x and y1. I highlighted that in pink. So you're going to take your calculator and you're going to do the ones in pink first. So we're going to do the -7 and the 12, the 2 and the 5.25, and the 17 and the -6. Do the regression, you get this guy. And then you're going to clear that out. Don't clear your x's because they're the same. Then we're going to take these x's and the different y's, and we're going to do a regression with that. So that's going to give us this guy. So stat calc, stat edit for each of these, write it down, and now we got to play the match game. Okay? So if we solve this guy for y, look what we get. Move the x, divide by what's in front of y, and oh my goodness, -3/4 is -0.75, and 6.75 is 27/4. You might have to do some fraction to decimal conversion. All right? If we check the second one, solving for y, move the x, change the sign, divide by negative, negative divided by negative is positive. Look what we get. We get what our calculator told us. So the answer to this, or the system, is right here, and the outputs are right there. All right, last one. Guess what we have to do? We have to solve for y. But after we solve for y, we're going to inspect the slopes and the y-intercepts. You remember back over here? What did we do in our first 3 examples? We looked at the slopes. Are they the same? Are they different? And then we looked at the y-intercept. And then we were able to determine how many solutions we had. So if we solve for y over here, we get this guy right here and this guy right here. What do I notice about the slopes? Slopes are the same. Slopes are the same. So same slope, -4/3, -4/3. Okay? What about my y-intercepts? They're different. Don't care how, but they're just different. So what does that mean? Same slope, different y-intercept. Same slope, different y-intercept. These guys are parallel. How many solutions do we have with parallel lines? None. Why don't we have solutions? They don't cross. So there's your answer.